The overview to this webinar is to master the ability to define acids and alkalis in terms of the ions they produce in aqueous solution and their effects and indicators. We also need to describe the characteristic properties of acids in reaction with metal bases and carbonates, and to state some uses of acids. We will also describe the characteristic properties of bases in reactions with acids, metal ions, and ammonium compounds. And finally, we will describe the pH scale as a measure of an acidic carbonate yield. Let's take a look at acids first. Okay, what are acids and how do we define them? Acids are substances that release hydrogen ions when it's dissolved in water. For example, we have sulfuric acid over here, which is H2SO4. When they're in the aqueous form, they will dissociate into hydrogen ions. In this case, there are two hydrogen ions, and we have the sulfate ions. The properties and reactions of acids are due to these hydrogen ions when they are dissociated in water. And substances that contain hydrogen may not be acids because they do not dissociate into hydrogen ions in water, for example, methane. So methane, we do have hydrogen in the molecule, but when you try to have methane in water, this hydrogen that is bonded to carbon will not be dissociated into water. So therefore, methane is not considered an acid, even though it has hydrogen in the molecule. Let us take a look at some of the common acids that we have around us. Okay, we have citric acid. Citric acid can be found in citrus fruits, soft drinks, and sweets. Okay, so example of citrus fruit that you see here would be your oranges, your limes, your lemons, grapefruits, pomelos. All these contain citric acid. And then we have our soft drinks. Our soft drink also contains citric acid. Then we have sweets that also citric acid. Let's take a look at one acid that we have around us. Ethanoic acid is another common acid that is found around us, which can be found in vinegar as well as tomato ketchup. There are also some common laboratory acids that you can find in the school laboratory. The first one is sulfuric acid, the second one is hydrochloric acid, and the third one is nitric acid. Some terms that are very important that you need to understand about acids. When we talk about dilute acids, we are talking about small amounts of acid that is being dissolved in water. When we describe an acid as concentrated, it means that we have a large amount of acid that is dissolved in water. The terms dilute and concentrated has different meanings from weak and strong, which is a common misconception that many students will make. When we describe a weak acid, what it means is this acid actually ionizes partially in water to give your hydrogen ions, whereas most of them will remain as molecules in water. A good example will be ethanoic acid, which we talked about it just now, which can be found in the vinegar. So ethanoic acid is a weak acid because when it's dissolved in water, not all of the ethanoic acid molecules are ionized completely in water to give you hydrogen ions. You only have some of the hydrogen ions that are ionized in water, but the rest remains as ethanoic acid molecules. But if we say that it is a strong acid, it means that the acid ionizes fully in water to produce your hydrogen ions completely. Good example would be a nitric acid or any of the common laboratory acids that you have. Let's take a look at some of the common laboratory acids that you can find in your schools. first one is your sulfuric acid. Sulfuric acid can be found in the school laboratory to be used in many of the experiments that you encounter. And of course, sulfuric acid can also be found in your car batteries. The next common laboratory acid that we encounter is called hydrochloric acid. And hydrochloric acid is actually found in our own stomach, which is one of the digestive juices that it has. Nitric acid is another common laboratory acid that you will use often in experiments. And nitric acid can also be found in some of the household detergents. Let's talk about the characteristics of acids. First of all, acids have a sour taste. Okay, so if you want to remember what is the taste of acids, just try to recall your citrus fruits. When you taste the citrus fruits, most of them has a sourish tinge. And vinegar is another good example. It is sour in nature because acids have a sour taste. And acids are capable of turning blue litmus paper red. It has a pH that's less than 7. Most importantly, acids are able to conduct electricity because of the hydrogen ions that are being dissociated into the aqueous form. We have free ions to actually allow electricity to be conducted through the aqueous solution. Acids are also corrosive when it's in the concentrated form, so handling of acids has to be very careful. And we also should know that acids are able to react with metals, alkalis, bases, and carbonates. So we are going to look at some of the common reactions that acids have. Let's take a look at the chemical properties of acids where it reacts with metals. First and foremost, acid will always react with metal to provide you with a salt and hydrogen gas. And then how do we test for hydrogen gas? We actually use a lighted spin in our experiment, and then this lighted spin will extinguish with a distinct pop sound, indicating the hydrogen gas is evolved during the reaction. But it's good for you to take note that not all metals are able to react with hydrogen ions in your acid because it depends on what is the position of the metal in the reactivity series. Okay, so for example, of metals that are able to react with acids in the reactivity series, they must be above the position of hydrogen. So such metals, example would be your potassium, your sodium, your calcium, your magnesium, your aluminum, your zinc, your iron, and lead. All these metals are capable of having reactions with acids to give you salt and your hydrogen gas. Now let's take a look at an example of acid reacting with metals. We take zinc metal. Okay, so zinc metal, if you react with a common laboratory acid, for example hydrochloric acid, what we end up with is actually zinc chloride, which is our salt, and of course our hydrogen gas. So what you see in the first row is the word equation for the chemical reaction of acids with metals. The second row shows a balanced chemical equation of the reaction of acids with metals, and you notice that in this case I need to have twice the amount of my hydrochloric acid in comparison to zinc in order for the reaction to take place. The next reaction that acids will have is the reaction with base and alkalis. So acids will always react with base and alkalis to produce salts and water. So the general equation for such a reaction is acid with a base or alkali giving you salt and water. And this particular reaction has a special name for it. The reaction is called a neutralization reaction. And if we talk about the ionic equation for neutralization reaction, it is always written as H plus ions plus your OH minus ions, giving you your water. Okay, the H plus ions comes from the acid, your OH minus ions comes from your alkalis, and your product is water in the ionic equation. So let's take a look at it. Alright, so in this particular example, we are reacting a base instead of an alkali with acid. So this base is actually iron trioxide, reacting with sulfuric acid giving you iron trisulfate and water. So in this case, this iron trioxide is not an alkali, it's called a base because it is not aqueous in nature, it's insoluble. So if it's insoluble, we call it a base. And if it's soluble, we give it a name called alkalis. We'll take a look at this particular naming in greater detail when we talk about alkalis later. But just bear in mind, iron trioxide is a base. Okay, so this particular iron trioxide, which is a solid, will react with the acid. In this case, we have sulfuric acid to give you a metal solution. In this case, this particular metal solution is iron trisulfate. Of course, we have water. So what you see over here, diagrams below, this is how it looks like. You have this reddish brown solid, which is iron trioxide, basically it's rust, reacting with a sulfuric acid to give you a brown solution. The next reaction that we are going to look at is acids reacting with carbonates. Acids will always react with carbonates to produce salt, water, and carbon dioxide gas. So this is the general equation. We have acid, we have a carbonate, forming salt, water, and your CO2 gas. And when you have a CO2 gas, in order to test for the presence of it, what we do is we connect it via a delivery tube and let it bubble through a reagent known as lime water. So this particular lime water, there will be a white precipitate that is formed in lime water in the presence of carbon dioxide gas, proving that carbon dioxide gas is evolved during this particular reaction. Good example in this case, we have sodium carbonate reacting with nitric acid to give me a salt, which is called sodium nitrate in this case, carbon dioxide gas, and water. Take note that sodium carbonate is actually a carbonate that is both existing as a solid, but this solid is actually soluble in water. So since it's soluble in water, you'll notice that we actually have aqueous as a state symbol. So there's actually sodium carbonate reacting with nitric acid, giving you sodium nitrate plus carbon dioxide plus water. So this is a reaction of acids with carbonates. And it is good to take note that since acids will always react with carbonates, this is actually a test for the presence of carbonate and ions in a particular test sample. Because if you actually react with an acid, you produce your carbon dioxide gas. Then of course we need to take a look at some of the uses of acids. Some acids are used to preserve food. For example, your pickles. Your pickles are basically small little cucumbers that are actually soaked in vinegar and it's actually preserved using your acids. Then we also use acids to remove rust because acids is capable of reacting with your iron trioxide, which is rust. Sulfuric acid is used in the manufacture of agricultural fertilizers. And of course, they're also used in the manufacture of your detergents, your paints, your dyes, your artificial fibers, and plastics. And then, not forgetting that we mentioned earlier on that dilute sulfuric acid is used in your vehicle batteries. After talking about acids, let's talk about bases. How do we define a base? Bases are basically metal oxides or metal hydroxides. We should actually react with acids to produce salts and water. Examples of metal oxides and metal hydroxides should be like iron trioxide, which we saw earlier on. We have our magnesium oxide, which is a metal oxide. We have our lithium oxide, which is again a metal oxide. And I have my sodium hydroxide, which is a metal hydroxide. Most of the bases are insoluble, except for bases which belongs to your group 1 metals and your ammonium ions. An example of group 1 metal oxide will be your lithium oxide. Because lithium is under group 1, so therefore group 1 metal oxides are soluble in water. And when we talk about alkalis, what we are referring to are called soluble bases. So when we have a base that is dissolved in water, it forms a metal hydroxide which is called an alkali. So in this case, I give you an example. I have potassium oxide. Potassium oxide is a metal oxide that belongs to group 1 oxides because potassium is under group 1. When we react with water over here, what you end up with is an alkali. In this case, this alkali has a chemical formula of KOH, meaning that it is potassium hydroxide. Next thing to take note is that alkalis are substances that release hydroxide ions when dissolved in water. So in this case, I have my potassium hydroxide. When it dissociates in water, it forms my K plus ions, which are the potassium ions in water. It also forms my hydroxide ions, which are my OH minus ions in water. And the properties and reactions of alkalis are due to the hydroxide ions. Some of the common base or alkalis that you can see around you will be your magnesium hydroxide. Magnesium hydroxide is actually a base because it cannot be soluble in water. Okay, and these things can be found in your toothpaste to neutralize your acids on your teeth. It can also be found in indigestion medicines to neutralize the stomach acids because they are capable of reacting with acids. The next common base or alkalis that you can find around us will be sodium hydroxide. Okay, sodium hydroxide, depending on whether is it in the diluted form or the concentrated form, they can always be found in some of the foodstuffs that we eat. Okay, so over here, sodium hydroxide can be found in lime water. Another name for lime water, sometimes they call it alkali water, and these are used in the preparation of foodstuffs. For example, in the Chinese dessert, we have the alkaline dumpling, which are made using your sodium hydroxide by soaking the rice inside it. And after the cooking process, you make the rice have a very gooey feeling. The same applies to a Malay dessert which is known as kuih lopes. It is also made by soaking the rice in the lime water. And of course, the third kind of food that we commonly see around us is the processed cuttlefish, which is soaked using lime water as well, and the cuttlefish would have a very chewy feeling. Okay, next kind of alkalines that you can see around us, again, sodium hydroxide, which is quite common, and these are used to make your solid soaps. The potassium hydroxide are actually used to make the liquid soaps. Now let's take a look at some common laboratory alkalis. There are four kinds of common laboratory alkalis. The first one is sodium hydroxide, the second one is potassium hydroxide, the third kind is aqueous ammonia, and the fourth one is calcium hydroxide, which is also known as lime water that we saw earlier on. And this lime water, if you recall, is actually used to test for presence of carbon dioxide gas. Just like the same way that we describe our acids, alkalis are also described in the same manner. We have dilute alkali, which means that a small amount of alkali dissolved in water. We have concentrated alkalis. Concentrated alkalis means we have large amount of alkali dissolved in water. And we have the same term that we used earlier on. We have weak, we have strong. So what it means over here is weak alkalis will ionize partially in water to give hydroxide ions, and most of them will remain molecules. A good example would be ammonia. Ammonia is actually a weak alkali. Strong alkaline will be alkalis that ionizes fully in water to produce your hydroxide ions. For example, would be your sodium hydroxide. Okay, some of the common laboratory alkalis that you see around the school laboratory will be sodium hydroxide, which we mentioned earlier on in the preparation of some of the soap and food products. But this laboratory alkali cannot be used to produce your food products because it's not food grade. So it's actually dangerous. Okay, so this sodium hydroxide can also be used to make your drain cleaners, to remove the clogs that you have in the drain system or your pipe system. The next kind of common laboratory alkalis will be potassium hydroxide. You will be able to find them in the school laboratory, and of course you can also find potassium hydroxide in alkaline batteries. The next kind of common laboratory alkalis will be aqueous ammonia. Aqueous ammonia can be found in the school laboratory, which is also one used to make the fertilizers. And aqueous ammonia has a very distinct pungent smell. And finally, we have our calcium hydroxide. Calcium hydroxide can be found in the school laboratory, which is used as a reagent to test for presence of carbon dioxide gas, also commonly known as lime water. So we can see over here below how the lime water actually has a white precipitate being formed inside it when carbon dioxide gas bubbled through it. Then, like any of the acids, alkali also has its own distinct characteristics. The first distinct characteristic is that it has a bitter taste. Okay, so for some of you who have accidentally taken soap during washing up, accidentally, you will actually experience this particular bitter and soapy taste that you have in your mouth. And because it's an alkaline, it is capable of turning red litmus paper blue. The pH value of alkalis are all more than 7, and it is able to conduct electricity because they are having your free mobile ions in the solution. One characteristic of alkalis is that it always feels slippery when you touch the particular aqueous solution, which is actually distinct feeling that you have when you touch your soap. However, alkalis are corrosive when they are in concentrated form, and alkalis are capable of reaction with acids, your metal ions, and your ammonium compounds. Let's take a look at the first reaction that chemical properties of acids have when they react with acids. Alkalis will always react with acids to produce salts and water, just like what we saw earlier on. If you recall, this is called a neutralization reaction. The ionic equation for neutralization reaction is H plus ions adding the OH ions to give you water. And then, if you want to prepare a salt that is obtained from the reaction between the acid and alkaline, there is a particular reaction as titration. that is being used. Okay, so for example, in a particular titration experiment, you can actually use sodium hydroxide, which is an alkaline, a strong alkaline in this case, reacting with hydrochloric acid, which is also a strong alkaline, producing salt and water. In this case, the salt is sodium chloride and water. And the picture below actually shows a typical setup of a titration experiment where we are able to produce an accurate amount of sodium chloride salt where required. And sodium chloride is actually a common chemical name for table salt, which is used in our cooking. The next reaction that we have for alkalines is the reaction with solutions of metal ions. When we have a few drops of sodium hydroxide that is added to a solution of metal ion, they will react to form an insoluble solid, and in this case there's a special name for this insoluble solid, which we call it as a precipitate. So the general equation is we have sodium hydroxide adding with our metal ions, and this precipitate is none other than our metal hydroxide, and of course it will have a salt solution in it. The reaction between sodium hydroxide and the solution of metal ions is called a precipitate reaction. This reaction is actually used to identify the metal ions, also known as the cation test in your chemical analysis chapter that we will look at it later on. So example of alkynes reacting with solution of metal ions is we have our sodium hydroxide. We add a few drops of sodium hydroxide to a solution of metal ion. In this case will be copper 2 sulfate, and copper 2 sulfate is a bluish solution. What you form is you actually form a blue precipitate, which is known as copper 2 hydroxide in sodium sulfate solution. So you can see from the diagram below that you have this blue precipitate that's being formed as a result of your sodium hydroxide reacting with your copper 2 sulfate solution in the test tube. Okay, next we have another reaction of alkalis, and that is the reaction with ammonium compounds. So ammonium compounds means they are compounds that contains ammonium cation. What is so special about this reaction is whenever alkalis reacts with ammonium compounds, you'll always produce ammonia gas. So we have our alkali react with the ammonium compound giving you salt and water and ammonia gas. Good example is back to our sodium hydroxide, which is a common school laboratory alkali, reacting with an ammonium compound, for example, our ammonium chloride. The salt that is formed will be none other than our sodium chloride salt with water with our ammonia gas. Okay, and ammonia gas has a very distinct pungent smell when the reaction is being carried out. After talking about acids and bases, the next thing that we need to talk about will be the pH scale. In the pH scale that you can see on the next page, over here, pH is actually to measure the acidity or alkalinity of a solution. And what does it mean by pH value is that if we have a value of 7 over here, 7 has a neutral pH value, which means that we have equal amounts of hydroxide ions and hydrogen ions in the solution. That means that it has a pH of 7. But if the event that we have more of the hydrogen ions compared to the hydroxide ions in this case, then it becomes more acidic. And the most acidic solution will have a value of pH of 0. And then we have a pH of 14 in this case. And pH of 14 means we have a greater quantity of hydroxide ions compared to hydrogen ions. So that is actually the pH scale. Let's take a look at the indicators used in the laboratory. An indicator is a substance that has different colors in acidic and alkaline solutions. There are a few common indicators that are being used in the school laboratory to indicate whether a solution is acidic or alkaline. Let's take a look at the first kind of indicator with the name called phenolphthalein. Phenolphthalein will be colorless when it's in the acid solution, but it will be pink in color if it's in the presence of alkalis. Then on the other hand, another common indicator is methyl orange. Methyl orange will actually be red in acids, but it will give you a yellow color when it's in alkalides. Then not forgetting, we also have our litmus. Litmus exists as two types, either the litmus paper or litmus solution. If you use the litmus solution will actually turn red in acids and will turn blue when it's in the alkaline solution. Then, of course, we have another kind of indicator, which we call it universal indicator. And what universal indicator does is that it has distinct colors, which are closely representing the colors of a rainbow in this case, that indicates each and every pH level of your solutions. And of course, besides using the indicators that you can find in the school laboratory, you also have natural indicators. Some brightly colored vegetables and flowers actually make very good indicators. For example, would be a beetroot, which you see in the first diagram. The second diagram is your red cabbage. The third diagram actually shows the butterfly pea flower. And when you actually extract the color out from these kind of vegetables or flowers, it can be used as indicators, and the diagram at the last over here shows how these indicators are capable of changing color in the presence of acids and alkalis. Okay, on the next slide over here, we are going to see how we can actually measure the pH of a solution in the school laboratory. The one that is commonly used is a universal indicator, which depends on the color change that you see in the indicator when you place the solution inside the indicator. So there is actually a chart that you can actually refer to see the different colors. And if you want a more accurate pH reading, there is such a thing known as a pH meter, which is shown in the diagram in the middle, that actually gives you an accurate reading of the pH value of the solution. Then, of course, if you want to actually record the pH values on a continuous data range, one of the ways is to actually make use of pH sensor connected to a computer. So this pH sensor is capable of detecting the pH values as the values changes, and this data is actually recorded automatically onto the computer by a suitable software. So these are the different ways of how a pH of a solution can be measured accurately. So I've talked about acids, I've talked about bases, and I've talked about the pH scale. Now let's do a recap of the things that we have mentioned earlier on. Let's take a look at acids. Acids are substances that release hydrogen ions. Hydrogen ions are H plus ions when they dissolve in water. Properties and reactions of acids are due to these hydrogen ions. Without these hydrogen ions, you will not have any appropriate reactions with the acids. Another term that we have said earlier on are dilute acids. What it means is that you have a small amount of acid that dissolves in water. Then we have concentrated acid. Concentrated acid means you have a large amount of acid that dissolves in water. Then we have another term known as weak acid. Weak acid means acid that ionizes partially in water to give you hydrogen ions. And most will remain as molecules in water, and such examples will be your ethanolic acid. Then you have strong acids. Strong acids are acids that ionizes fully in water to produce hydrogen ions. Examples of strong acids will be your school laboratory acids such as nitric acid, hydrochloric acid, or your sulfuric acid. Let's recap on the characteristics of acid. Acid has sour taste. It actually turns a blue litmus paper red. It has a pH that's less than 7. It's able to conduct electricity. It is corrosive when it's in the concentrated form, and is able to react with metals, bases, alkalis, and carbonates. Then let us recap on bases. Bases are actually metal oxides or hydroxides that react with acids to produce salts and water. You have to take note that most of the bases are insoluble, except for bases that belongs to a group of metals or your ammonium ions. When you have a base that dissolves in water, it forms a metal hydroxide which has a special name known as alkali. Alkalis are substances that release hydroxide ions when they are dissolved in water, and the properties and reactions of alkalis are due to these hydroxide ions. Next, we talk about the properties of alkalis. Alkalis have a bitter taste. They turn the great litmus paper blue. They have a pH that's more than 7. They are able to conduct electricity, and if you touch it, it feels slippery to the touch. Again, if it's in the concentrated form, it is corrosive, and they are able to react with acids, metal ions, and ammonium compounds. And finally, let's read on the pH scale that we have mentioned earlier on. pH is a measure of how acidic or how alkaline a solution is. And an indicator is a substance that has different colors in acidic and alkaline solutions. And how a pH value of a solution can be measured? There are 3 methods. The first method is to use a universal indicator, where there are color changes for different values of your pH for the solution. Then, of course, you have a more reliable method, which is the pH meter, which will actually record the pH values for you, which will display it on the pH meter, which is a more accurate measure compared to universal indicator. Then, of course, if you want to measure the pH solutions continuously over a range, you have to use the pH sensor that's connected to a computer so that you are able to see the changes in the pH values. Yeah, and with that, we actually come to the end of the acids and bases and pH scale webinar for today.